Find the derivatives of each of the following functions. Y is equal to 4x to the power 3 minus 5x squared plus 4. This is a simple polynomial where x's are raised to certain powers. To find derivatives of such functions, we just introduce the notation dy dx and apply the power rule. So to differentiate, we multiply this power by the coefficient. 3 times 4 is 12. Then we drop this x. Then you reduce the power by 1. 3 minus 1, we get 2. Going to the next term, the power is 2, the coefficient 5. 2 times 5, we have 10. We drop the x, reduce this power by 1, 2 minus 1, we have 1. This term is a constant term. The derivative of a constant term is equal to 0. So the derivative of 4 is 0. We can simplify this. We have 12x squared minus 10. X to the power 1 is better written as x without a 1. So x to the power 1 is just the same as this x. Then this 0, we can remove it. On the other side, we have y is equal to 2, or in parentheses, square 3x plus 4. To find the derivative of such a function, we apply the chain rule. So for the chain rule, we look at this coefficient and the power. So we multiply this. 2 times 2, we get 4. So we create enough space. So we have 4. 2 times 2, we have 4. Like that. Then we drop the whole of this thing now, since the power is on the whole of this. So we say 2 times 2 is 4. Then we drop the whole of this thing, which is 3x plus 4. We close. Then reduce this power by 1. So 2 minus 1 is 1, like that. Then the final procedure, we look at what is inside here. So you just have to take the derivative of what is inside. So when we differentiate what is inside, what do we obtain? So let us differentiate the inside. So to differentiate the inside, we say the answer, we put it here. So this is 1 times 3. We have 3. Then reduce this power by 1. So we have x. So we have 1 minus 1 here. We get 0. Then this 4 is a constant. So the derivative of a constant is 0. So we say 0, like that. Then we close. So that is the derivative of the inside, 3x to the power 0 plus 0. We can simplify this expression. So we have 4, then 3x plus 4, close, 1, then we have this. X to the power 0 is 1, since a number to the power 0 is equal to 1 apart from 0. So x to the power 0 is 1, and 1 times 3, we have 3. 3 plus 0 is 3. We can rearrange this expression so that we have these numbers together. Multiplication allows us to do that. When we have, for example, 1 times 3, we get the same result as 3 times 1. So we can rearrange this, obtaining 4 times 3 times 3x plus 4, like that. 4 times 3 is 12. Then we introduce this. We have 3x plus 4, like that. We can also distribute this 12 with whatever is in parentheses. But this is the answer. just another example for proper comprehension. Let's consider y is equal to 5x minus 7 to the power 2, like that. So we apply the chain rule. Now, the rule says, look at the coefficient and the power. So the coefficient here is 1. So we multiply 2 times the 1, we have 2. Then we drop down the whole of this thing, which is 5x minus 7. Then we close like that and reduce this power by 1. So 2 minus 1, we have 1. Now we open parentheses here and take the derivative of the inside function. So the derivative of this part, we say, there's a 1 times 5, we have 5. Then we drop the x, reduce this power by 1. 1 minus 1, we have 0. Minus the derivative of a constant is 0. We close. Simplifying this, we have 2, 5x minus 7, like that. Power 1 is better written just like that without a 1. It's just the same. We continue. X to the power 0 is 1. 1 times 5, we obtain 5. And 5 minus 0 is just 5. We multiply these two numbers. We can rearrange. We have 2 multiplied by this 5. We put it here. Then lastly, we have 5x minus 7, like that. And 2 times 5 is 10. Open parenthesis, 5x minus 7, like that. So this is differentiating using the chain rule. Thank you very much for watching.